multi-variable linear systems. Guys, what does multi-variable mean? More than one, right? If you look at this example, we have 3 variables, right? If we have linear systems, that means everything is raised to what power? The first power. Okay, we don't have any squares or anything like that. What you need to be aware of is when you're solving these, notice your x's, your y's, your z's, and your constant. What do you notice about them? Okay, all lined up. You might be given problems where they're on different orders. Just order them accordingly, right? So signs that are in front of each term, go with it, and order them accordingly. So what we're going to do is we're going to eventually, at the end of this lesson, we will have a set of 3 equations with 3 variables that looks like this, and we'll make it look like this, and then we'll solve it. All right? Don't worry about the vocabulary that's behind it. If I asked you guys to solve this right here, everyone in here right now could do this. What would you do? You would take z right here and plug it in right there, right? And solve for what? Y. Then you would take your z and your y and plug it in here and solve for what? X. And you'd get your 3 answers. You'd get your x, your y, and your z. That's called back substitution. Everyone in here can do that, no problem. The way that you write your answer, you don't leave it as x equals, y equals, z equals. You write it as an ordered triple. The reason it's called an ordered triple is because there's 3 instead of an ordered pair, which is 2. Okay, does that make sense? You guys see that? We're okay? All right. So here, solve this system of linear equations. If I didn't even teach you guys, if I didn't even speak to you today, you guys could all figure out how to do this. The biggest thing I'm going to stress to you today, boys, I talk to you a little more about this than the girls because it just generally happens that way. You need to be organized, right? Some of you, when I go to grade your papers, goodness gracious, it's like a scavenger hunt trying to find your work. Be organized. Makes everything in your life easier, especially when it comes to this stuff. So the first thing I'm going to do is over here, I'm going to write z equals 2 because I already know they're telling me that z equals 2. So now I'm going to use back substitution, and I'm going to take 2, and I'm going to plug it in right there to solve for what letter? Okay, we're going to solve for y. Good. So I'm going to say y plus 4 times 2 equals 7. Y plus 8 equals 7. Subtract 8 from both sides, yes? Y equals negative 1. So over here, I'm just going to write y equals negative 1. And now what am I going to do? I'm going to take this negative 1, I'm going to plug it right there. I'm going to take this 2, and I'm going to plug it right there, and I'm going to solve for what? Okay, so I'm going to say x minus 2 times negative 1 plus 3 times 2 equals 9. This is where you guys will make mistakes. Some of you will rewrite that, and you'll say equals 7 because you looked at the wrong equation. Or you'll miss that there's a negative 2 and a negative 1, which becomes a what? Positive. Like little stuff like that makes a ginormous difference. But if you're going to solve for x here, I have x plus 2 plus 6 equals 9. Agreed? 2 and 6 gives me 8. Subtract 8 from both sides. And I get x equals how much? Positive 1. So over here, I'm going to write x equals 1. Now, if I leave my answer like this, a 10-point question, am I getting all 10 points? No. How does my answer need to be written? As an ordered triple. So 1, negative 1, 2. There's my answer. Now, the reason I tell you to come over here and write this is just to keep yourself organized. So you're not looking all over your paper with where did I solve for y? Where did I solve for x? Very easily, I could have forgotten that negative on the y. Or I could have switched the places of positive 1, negative 1. Does that make a huge difference? Absolutely. When you get your ordered triple, just take 2 seconds and plug it into the first equation to make sure that it works. So I had x is 1 minus y was negative 1. So I have minus 2 times negative 1 plus 3 times 2. Does that equal 9? Well, 1 plus 2 is 3, and 3 plus 6 is 9. You're good to go. Questions? Questions at home? What's up? All right, next question. Show that the ordered triple is a solution. Yes, sir. Show that it's a solution. Guys, I don't want you to just, if you have a question like this that says, is the ordered triple a solution, or show me, you actually have to show me. Meaning, write it down. 2 seconds. They told me to plug in 1. Correct, that's a bad color. They told me to plug in 1 for x, right? Minus 3 times 0 for y, plus 2. Does that equal 3? All right, well, this crosses out. What's 1 plus 2? Does 3 equal 3? Okay, you're good to go. Can I just move on and say, oh, yeah, this one works for all of them? No, you got to check. Take 2 seconds to, excuse me, sorry. 2 times 1 plus 0 minus 5 times 2. Does that equal negative 8? Well, what's 2 times 1? 2. Minus, plus 0, nothing. Minus 10. What's 2 minus 10? Does negative 8 equal negative 8? Good to go. Last one. We're going to plug in 1 minus 0 plus 3 times 2. 1 minus 0. What's 1 plus 3 times 2, which is 6? Does 7 equal 7? Good to go. So did you just show me that this ordered triple is a solution for this system of equations? Yes. Do you have to check all of them? Yes. Then you know. Good question. What happens if you plug them in and one of them didn't work? Then no, it's not a solution for that set. All right, solve using back substitution. Again, I'm going to go through this one relatively quickly. I'm going to say z equals 8. Now I'm going to take this 8, I'm going to plug it right there. So y plus 2 times 8 equals 6. Y plus 16 equals 6. What does y equal? Negative 10. So I'm going to say y equals negative 10. Now I'm going to take y, plug it in there. I'm going to take z, plug it in there. I'm going to solve for what? So 2x minus, this is where you got to be careful, minus a negative 10 plus 5 times 6. Does that equal, or it equals 24? 2x minus the negative is plus 10 plus, this shouldn't be 6. See, I put in the wrong number. What's 5 times 8? 40 equals 24. What happens with 10 and 40? 2x plus 50 equals 24. Now what? Subtract 50. 2x equals, oh wow, negative 26. And then divide both sides by 2, so x equals negative 13. So I'm going to write up here x equals negative 13. And then how do I write my answer? Negative 13, negative 10, positive 8. And how do I know that they're right? I know I did the work, but how do I know? How do I check and say, okay, before I move on, I know that this is right. Plug it in to the original, to the first one with all 3. Just to check, just to make sure. Make sure that negative 10 should be negative and it's not positive and you forgot or that you added the negative sign or something. Just check. All right, we good? All right, moving along. You guys can read. I know you all can read. So what we're about to do is what this slide says. Okay, I'm not even going to read through it. I'm just going to show you. And after we do 1 or 2, you guys are going to be good to go, I promise. All right, this is called Gaussian elimination. Do you see how this looks a little different from what we just did? Yeah. I have 3 equations, but they all have 3 variables. So what we're going to do, our first step, is we're going to make our equations look like they first did at the beginning of our examples, where the first equation has 3 variables, the second equation has 2, and the last equation says z equals. Then we're going to solve it. So the way that we do that, the first rule you have to write down, and you have to do this every single time. The first equation, write this down, must start with positive 1x. It's a 1. Positive 1x. If it doesn't, you have to make it. You have to turn it into that. And I'll talk to you about that in 1 second. All right, so when we use our Gaussian elimination, the first thing, if the first equation has to start off with positive 1x. If it doesn't, which in some examples it won't here, you can move them. They're interchangeable. You can move the top one to the bottom and that sort of thing. Or you could, if everything started with negative, how could I make the second equation start off with a positive 1x? Divide everything by -1, perfect. If there's a GCF, you could take it out, something like that. You just have to think a little bit. But what you're going to do, once we have our initial first equation starts off with positive 1x, we're good, right? So we're going to take the first two equations, write them down, x minus 2y plus 3z equals 9, and negative x plus 3y plus z equals -2. Okay, what we're trying to do is we're trying to have a system of equations. We have our first one already with 3 variables. So the second equation should have how many variables in it? 2. So we're going to get it to be like that. So the first thing you do, you always want to cancel out x's first. This is already set up for us that x's are canceled out, right? So when I combine them, what happens to my x's? Positive and negative cancels out, yes? Negative 2y, positive 3y is y. 3z plus 1z is plus 4z equals, what's 9 minus 2? 7. There's our second equation. Y plus 4z equals 7. Very easy to make mistakes by recopying, so make sure you're paying attention. So now what should the third equation over here in my little bracket, what should it say? It should just be z equals. So the way that we do that, okay, we're going to take the first and the third. So x minus 2y plus 3z equals 9. And then the third is 2x minus 5y plus 5z equals 17. And we're going to cancel out x's. So what would I multiply the top equation by so my x's can cancel out? What kind of 2? A -2, right? So if you need to tell yourself, don't forget to go to every single term, do that. So I have -2x plus 4y minus 6z equals -2 times 9 is -18, okay? This is gone now. So combine. What happens to my x's? They cancel out. I have -5y and a positive 4, so -y minus z equals -1. Agreed? All right, what did we say we want our last equation to say? Just z. So what do you think we do with the 2 blues that are left over? What do you think I do? You combine those. So y plus 4z equals 7. -y minus z equals -1. Cancel out your y's now, because all you wanted to say is what? Z equals. So my y's cancel. What's 4z minus 1z? 3z. What's 7 minus 1? 6. Guys, what does z equal? So z equals 2. Now we're not done. We did the hard part. But if you're going to solve, that means I want to know what x equals, what y equals, and what z equals. So this is part 1 that you're going to get credit for. And then how do you think I now figure out what my ordered triple is? What was that? You plug everything in. We're going to do our back substitution. So over here, I'm going to tell myself that z equals 2. So I'm going to say y plus 4 times 2 equals 7. Y plus 8 equals 7. Subtract 8 from both sides. What does y equal? Okay, so y equals -1. And then now what do I do? Yep, plug it into the top one. So I have x minus 2 times -1 plus 3 times 2 equals 9. X plus 2 plus 6 equals 9. X plus 8 equals 9. What's X equal?
1.
So if I'm going to write my answer, and I'm so proud of myself that I got my 3 answers, how does it look? 1, -1, +2. Questions? Terribly difficult? No. Pain in the butt? Yes. But the way that we do this, first of all, we make sure that first equation has a +1x. Then you take the first and the second, eliminate the x's. That gives you your second equation. Then to find what z equals, you take 1 and 3, cross out x. Take the 2 leftovers, cross out y, and then you get z. But if you keep yourself organized, it's not terrible. Isn't this fun?
No.
Oh. Okay, we're going to solve this. What is my initial issue? What's the problem here? There's a 2. What would be the easiest thing to do in order to get my first equation to have a +1x? Move the second one where? To the top. You could do that, so just rewrite it. I'm going to rewrite this as x minus 2y plus z equals 8. And then I'm just going to write 2x plus y plus 3z equals 9. And then I'm going to say negative 4x plus 3y plus 2z equals -4. And I'm going to take a second and I'm just going to make sure I rewrote everything correctly. Did I make any mistakes with signs or anything? Okay, so we're no longer looking at this. So the first thing we're going to do is we're trying to get 3 equations. One that has 3 variables, one that has 2, one that has 1. Then we're going to solve. So over here, I'm going to keep myself organized. I already have my first equation, x minus 2y plus z equals 8. So now I got to find that second equation. So I take the first 2, x minus 2y plus z equals 8, and I take the second one, 2x plus y plus 3z equals 9, and I'm going to eliminate x's. So what am I going to multiply that top equation by? What kind of 2? -2, because you want it to be exact opposites. So I'm going to remind myself I have to go everywhere, every term on both sides. So this is going to become -2x plus 4y minus 2z equals -16. Everybody agree? Okay, so this is gone. Now when we combine, what happens to my x's? They cancel. So 1y and 4y is 5y. What's 3z minus 2z? 1z equals, what's 9 and -16? -7. There's my second equation. So I'm going to go up here, I'm going to rewrite it. 5y plus z equals -7. All right, what's the last step? What does my last equation need to look like? Just z equals. All right, so we have to do 2 things in order to make that happen. We're going to take the first and the third. So x minus 2y plus z equals 8. And -4x plus 3y plus 2z equals -4. What do I have to multiply the top by? +4, good. So I have 4x minus 8y plus 4z equals 32. Agreed? Okay, this is gone now. X's do what? Cancel. What's 3 minus 8? -5y. What's 2 plus 4?
6.
Plus 6z equals, what's 32 and -4? 28, all right? Now, what were we trying to do? We're trying to get what? Z equals. Do I have 2 equations that I can combine and get it to say z equals? Yes, so 5y plus z equals -7. negative 5y plus 6z equals 28. Now, it just so happens, guys, that this works out. You might have to multiply something by the top or whatever to get the y's to cancel out. But 5y, negative 5y cancels. What's 1 plus 6? So 7z equals? 7z equals? 21. What does z equal? Perfect. So up here I write down, look at me, I'm so smart, z equals 3. That's the first part of your answer. Now, in order to find out what x, y, and z are, what do? Plug it in. Back substitution. So I know that z equals 3, so then I'm going to take z, and I'm going to plug it in. So I have 5y plus 3 equals negative 7. Subtract 3 from both sides. 5y equals negative 10. So what's y equal? There you go. And now I have to find... What's up?
Is that a, unlike all the 9, is that a 6 as well? The blue, like, 22?
That's 2z.
Oh.
I don't like z's. The next one I'm going to write with my best handwriting ever, I promise. I have to slow down a little bit to do that, but okay. All right, so now I'm going to say x minus 2 times negative 2 plus z, which is what? 3 equals 8. So x plus 4 plus 3 equals 8. X plus 7 equals 8. What's x equal, guys? So how do I write my answer? The negative. 1, negative 2, 3. And then how do I know that I'm right? What do? Plug it back in, just to make sure. Two more. Okay, here we go. What do I need to look for first? Does the first problem, the first equation start with positive 1x? Yep. So I'm just going to rewrite it as x plus y plus 3z equals 7. So now I'm going to take 1 and 2 and combine them. X plus y plus 3z equals 7. And 2x minus 4y plus z equals 7. What do I have to multiply the top by so my x's will cancel out? Okay. So I have negative 2x minus 2y minus 6z equals negative 14. Agreed? Okay, combine. Positive 2x, negative 2x. Nothing. Negative 6, negative 2. Sorry, negative 4, negative 2. Negative 6y. Positive 1 minus 6. And then 7 minus 14. Yep, so there's my second equation. Negative 6y minus 5z equals negative 7. Now I got to find the last one, and it should just say z equals. So we have to combine 1 and 3, right? X plus y plus 3z equals 7. And 3x plus 5y minus 4z equals negative 6. What do I multiply the top by? Negative 3. Good. There, and there. Negative 3x minus 3y minus 9z equals negative 21. Everybody with me? X's cancel out. So I have 2y minus what? 13z equals what? Negative 27? Did I make any mistakes anywhere? We're okay? What does my last equation need to say? Just z equals. Are we close to that? Yes. What do? Combine these two right here. So negative 6y minus 5z equals negative 7. And 2y minus 13z equals negative 27. Now what? Okay, multiply the bottom one by 3. It's a good plan. So I'll do this over here. Negative 6y minus 5z equals negative 7. So when I multiply, I get 3 times 2, 6y. What's 3 times negative 13? Good, negative 39z equals, what's 3 times 27? How much?
81.
Yep, so negative 81. Combine your y's, what happens? Cancel. All right, what's negative 39 and negative 5? Negative 44z equals, what's negative 7 and negative 81? Negative 88. So now I divide both sides by negative 44. And I get z equals positive 2. So I'm going to come up here and I'm going to say z equals 2. All right, that's the first part of our answer is I got my equations into 3, 2, 1 format. Now, how do I find out what the ordered triple is? Plug it back in. Okay, good. We're almost done. So I'm going to say negative 6y minus 5 times 2 equals negative 7. Negative 6y minus 10 equals negative 7. Agreed? All right, we're going to add 10 to both sides. Negative 6y equals 3. So y equals what? Negative 1/2. Oh my gosh, we got a fraction. We should just quit. What makes this a little easier for us? How can I rewrite that? But how can I write negative 1/2? No, I can also write it as negative 0.5. If you would rather, as long as it's a terminating decimal, meaning one that ends, not like 0.33333 with a line over it. If you get a terminating decimal, I'm okay with you guys changing it to a decimal. Because I understand you guys don't want to plug a fraction back in. Okay, no big deal. So now that we have our x and our y and our z, are we going to find x now, right? So x plus, instead of y, I'm going to put negative 0.5 or negative 1/2, whatever you want, plus 3 times 2 equals what? 7? So x, what's negative 0.5 plus 6? What's $6 minus 50 cents? 5.5, good. So plus 5.5 equals 7. So x equals, I got $7 and I took $5.50 away. $7 minus $5.50. 7 minus, what is it? $1.50. Guys, as soon as you see decimals, just think money. So how do I write my ordered triple here? X is what? 1.5. What was y? Negative 1/2 or negative 0.5. And then what was z? 2. Do you guys see why I think it's a good idea to write somewhere x equals y equals z equals? So you're not going, wait, where did I put z? Wait, where did I put? It's just easier to do that. The answer here could also be 3/2, negative 1/2, and positive 2. I don't care, as long as it's a terminating decimal, meaning it doesn't repeat when you put it in your calculator. We all right? Okay, we got a fraction. Not a big deal. Everybody's okay. We lived through it. Last one. Pablo, what? Can you wait 2 more minutes? I'm almost done. Andrew.
We were supposed to be called down at 1 o'clock.
Get you. I promise. Promise. All right, same thing. What are the rules? We're going to do this one fast. What are the rules? First equation. Pablo says x has to be like that. Correct. The first equation needs to be positive 1x. So I'm going to write over here, and I'm going to say x minus 3y plus z equals 1. All right, so now I'm going to take 1 and 2. X minus 3y plus z equals 1. 2x minus y minus 2z equals 2. What do I multiply the top by so my x's will cancel out? Negative 2. Great. Boom, 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 boom. Negative 2x, positive 6y, negative 2z equals negative 2. Agreed? Okay, cross that off. X's cancel. What's negative 1 and positive 6? 5y. What's a negative 2 and a negative 2? Negative 4z. And I have 2 minus 2 is 0. So there's my second equation. 5y minus 4z equals 0. 5y minus 4z equals 0. Questions? Now what do I do? How do I find the next one? First and third. Good. X minus 3y plus z equals 1. X plus 2y minus 3z equals negative 1. Multiply the top or bottom by what? Negative 1. I'm just going to do the top, right? Guys, watch. I'm just going to change the signs. I'm not going to rewrite anything. This becomes negative. This becomes positive. This becomes negative. And this becomes negative. Is everybody okay with that? Okay, so what happens to x's? Cancel. So I'm left with 5y minus 4z equals what? Negative 2. Okay, so now I have these two. I already have an equation that has 3 variables. I already have an equation that has 2 variables. I need my last equation to have just 1. So I'm going to combine these two. 5y minus 4z equals 0. 5y minus 4z equals negative 2. How do I combine them? What do I have to do? Okay, multiply with negative. So I'm going to say just the top one. This becomes negative, positive. Is negative 0 a thing? Okay. So combine negative 5y, positive 5y. Nothing. 4z minus 4z. Nothing. So I'm left with nothing over here equals negative 2. Is that true? So what's my answer?
Miss Meadows,
No solution. Yes, sir.
can you do that over again, please?
Sure. When you end up with 0 equals a number or an untrue statement, that's no solution. If you ended up with 0 equals 0, then what would my answer have been? Infinite many. Very good. And if you come up with z equals whatever, then that's what you got. So this would be no solution. Now, you have to go through that work to find that. There's no way anybody in here, unless they read an inconsistent system, looked at this and they're like, obviously it's no solution. Right? That's not obvious to anybody. So, I know this video was long. You guys did a great job today.